spots. Solving exponential and logarithmic equations. Now, last hour we got through, there's going to be about, I don't know, 5, 6 different forms of solving logarithmic equations. And it's up to you guys to be able to decipher which method you have to use. Some of them are a lot more obvious how to solve than others, but it just takes a little getting used to. So this is going to look a little bit weird to start with, but after a few examples, you're going to fly right through them. People really seem to do rather well with these things. So here's what we've got. What we're going to wind up with here today are equations that look like this. And a big giant hint. We have 4 to the 3x equals 8 to the x plus 1. Now, in order for us to be able to solve these style equations, there is a very large hint involved in a base. So what you want to be able to do for these types of problems is that we're going to be working back and forth within our bases. So we want to be able to rewrite equations with different bases. Now, between a 4 and an 8, they have a common base of 2. 4 is 2 squared, and 8 is 2 cubed. Do you agree on that? All right. So what happens here is that you want to rewrite this as 2 squared times 3x equals 2 cubed times x plus 1. Yeah. Oh, what happens here is that when you have like a 4 and an 8, a 9 and a 3, a 3 and a 27, things like that, you want, with things raised to exponents, you want to be able to create a common base. Because once you create a common base, the exponents drop. So now you wind up with, well, what's 2 times 3x? And it's 3x plus 3. So what we wind up getting here, oops, that's a little bit better. What you wind up getting then is by creating this common base, your exponents are equal to each other. And now you wind up with a very simple 1 or a 2-step equation. Everybody see that? What's that? It's pretty cool. And what's x? Okay. So what happens here then is that you're solving your answer. Once you get your answers obviously for x, the next little thing is just to always quickly double check, make sure it did work. Okay. And sometimes you'll get those extraneous solutions, you have to check for them. So it's 4 to the 3 times 1, and then 8 to the 1 plus 1. So 4 cubed and 8 squared, and 64 equals 64. So it works. Yes, sir? What? Once again, you have to create common bases. Rewrite a 4 and an 8 to have the same base. 4 and an 8 have the same base of 2. 4 is 2 squared. 8 is 2 cubed. Okay. I know the papers were going back, so that's not big. I'll show a couple more like that. Okay. Yes, ma'am.
Those bases disappear or what?
What happens? Once they don't cancel, but what happens is once these bases are common, that means you can set the exponents equal to each other. Once you have common bases on both sides, with nothing else tacked onto it, you just set them equal to each other and it works. All right. Another example, just like this. 9 to the 2x and 3 to the x minus 6. So in this instance here, we have 9 to the 2x and 3 to the x minus 6. I want to create a same common base. So in this case here, the common base that I'm going to use is what? 3. Very good. That means I have to rewrite 9 with a base of 3. How do you do that? 3 squared. So that means this becomes 3 squared equals, yeah, times 2x equals 3 to the x minus 6. Now, once again, our bases are the same, which means our exponents have to equal each other. Yeah. It doesn't work going the other way. Work your way down. Yeah, work your way down. Work your way down.
After you get the equal bases, you just ignore bases and go straight to the exponent.
Yep. You get -2. Okay. So does 9 to the -4 equal 3 to the, what was that? To the -8. Does that equal each other out? It will. It will. Just look at the other one I have up here. What are you going to use for a common base here? 2. So it's going to be 3x equals 2 times the quantity x minus 1. And it's got the weird face.
I just want to
Always work down. Go to the smaller one. All right, it's always going to work cleaner that way. All right, it doesn't work the other way around. So you wind up with 3x will equal 2 to the x minus 1. All right. So you wind up with x is 1.
What happens if you get weird looking numbers that don't have a common base?
Then you can't do it. Then you have to do something else. We're not that far yet. Yeah.
wait till that 2x squared minus 1 simplifies to 2x minus 2.
Oh yeah, it would be minus x minus. Yes, thank you. And I did the thing that most people forget to do. Distribute to the second term. Yeah, so x should equal -2. Thank you. Yeah. This is one way that you're going to see.
2 squared, and then parentheses 3x, right?
Yeah.
Was that
No.
not right?
This already has a base of 2. Oops.
Yes.
This is 2 squared to the x minus 1. So that's where I get 3x equals 2x minus 2.
So x is equal to
Yeah.
Okay.
See, you must go the other way. Because x is
Don't go the other way. Work your way to the smaller number.
x is equal to
X is -2. But wait, there's more. What happens when you don't have anything going on? No common stuff, like you were just saying. What are you going to do now? Well, this didn't show up very clean. This is the same thing as saying, oops. Two to the x equals 7. So that means I have to figure out some way to get the x out of the exponent. Ooh. Can't do that. Can't do that because I've got a base in front of it. So remember the properties of logarithms. Log base b of b to the x. What does that equal? No, just looking at this right here. Log base b of b to the x. It's what? It's just x. Okay? The two bases simplify themselves out, and you're left with the exponent. Now, in order for myself to be left with just the exponent here, what would I have to take the log base on both sides? 2. Take the log base of 2 of both sides. X is the log base 2, 7. That's going to give you a decimal answer because your calculators will figure out change of base for you. They will do change of base for you. And you get some decimal. At least you should. What'd you get? 2.81? Okay. If you can't find log, remember you can do change base real quick by just doing log of 7 divided by log of 2. That's another way of doing it. There's a little boatload of stuff. So what do you have to do for this guy here? 3 to the x is 14. Yeah, just take log base 3 of both sides. So you wind up with x equals whatever the log base 3 of 14 is. What'd you guys get? 2.4 or something?
It's 0.
Oh, okay. Not so bad, is it? I mean, it looks weird, but the steps that we're doing to solve most of these things are relatively easy. Okay?
You take whatever number has the x with it, like the base.
Yeah, because you want to get that x out of the exponent out of the air, if you will. Okay? Now what do you think you gotta do? Ten to the 2x minus 3 plus 4 is 21. Perfect. First thing you gotta do, move the 4. Very good. Now, how do I move that exponent? How do I get that out of the air, if you will? Log base 10. Very good. So I have to just take the log of both sides. So you wind up with 2x minus 3 is the log of 17. Now I'm going to stop here for a second. The log of 17, do we agree, is just going to be some number? Some decimal, whatever it is, right? So I'm not going to figure out what that is until I'm done moving everything else over. In order to get x by itself, the rest of this problem, do we agree that we have to add 3 and divide by 2? Okay. So that means that x is going to equal the log of 17 plus 3 all over 2. So now I'm going to use my calculator, and you have to be careful when you type this into your calculator, is that when you hit the log button, remember I don't have to worry about my base here because it's a base 10. When I hit the log button, what opens up? Parentheses. You gotta close it right away. Add 3, hit enter, divide by 2. Okay. Gotta be careful with your order of operations when you're typing this into your calculator. Yeah. Yeah, just sometimes people when they do that, they don't just start in the calculator. That's why I'm saying to break it into to write it out first. But what you're saying is fine.
Okay.
Just because what people would normally do is they'll find the log of 17 and write down a decimal, and they might have a rounding error later. Sorry, go ahead, Isabel.
I got a log here.
Let me see what you typed.
Oh, I just deleted.
Oh, why'd you do that? Oh, we can hear it through this. No, I don't know what you did. Try again. All right. Okay, let's solve this one then. Did you get it again, or did it work?
I got it. No, I got it.
You got it? Okay. Yeah. Did I put the plus on here? Yeah. See. That's why I had to go through all these. Yeah. See, I've already fixed all these, and they're all back in the sky. They're correct now. There's a real quick, easy way to set this one up too. Might be overthinking it. Or if you guys just take the log on both sides right away.
Yep.
That's fine. If you take log most ways, you're good at the same thing. I'm going to show you something that works just as quick. Take a look at this, guys. this is 10 to the 3x minus 4. Do you agree? 0.1 is the same thing as 1/10, right? Which means this is 10 to the negative 1. Do you guys get the same answer?
Yeah.
That's fine. I just recognize I can rewrite it at the same base. That's okay. You get the same result. All right? You're going to get the same result. If you took the log on both sides, it's going to give you the same thing. Okay? Not too bad. Now, the other fun stuff. Words, 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 blah, blah, blah. Equations that look like this. Log base 3 of 5x minus 1 equals log base 3 of x plus 7. Do you see anything in common on both sides of the equation? Log base 3. Does anybody else see anything else in common? Just log base 3 is all I'm saying. Just trying to be silly here. Now, since this is the same log base on both sides, what do you think I'm going to do next? What's that? Yeah, I guess you could say that. Since I have the same log base on both sides, and there's nothing else there to worry about, Isabel, I think you have the answer already.
Yeah, it's 2.
X is 2. Now, once again, real quick thing to double check yourselves. Just substitute back in. You wind up with 10 minus 1, so you get log base 3 of 9 and log base 3 of 9. Last time I checked, log base 3 of 9 equals log base 3 of 9. So if you get the same results, you're doing okay. Not so bad? It's not less scary than you thought, is it? Okay, now what do you do? Try that one out. Oops. So here, we have the same log bases on both sides. Okay, so you have x plus 2 is x squared. Cry and hide? Leave it. Go to the next problem. All real numbers. Circle it and say, Murph, you do this tomorrow? Isabel, what'd you do?
Well, you move x and 2 to the other side.
Set one side equals 0, ladies and gentlemen.
Yeah, and then you get group
Oh.
2 and x plus 1.
Factor. 1 times what's negative 2? You add together to get negative 1. And your zeros were?
But only 2 words.
What?
That's what I got.
Well, take a look. Negative 1 plus 2 is 1. Negative 1 squared is 1.
Oh, wait, no, I did that wrong.
They both work. Okay? You wind up with log base 2 of 4 equals log base 2 of 4. It might. It might. So you always want to double check for those extraneous solutions, okay? You always want to check and see it, just in case there is one that doesn't work. All right? In Isabella's case, she probably forgot to put the parentheses around the negative symbol when she pressed the squared button. I'm just saying.
Yep.
Yeah. Okay? Does that make sense, guys? You will see that from time to time. So if you do see something that has a squared term, you probably have to factor. Okay? All right? Log base 5 of 2x plus 15 equals log base 5 of 3x. What's that? I hope so. It's still early. Just wait for the other shoe to drop here, aren't you? You guys get 15 for this one?
Yeah, sir.
Everybody see why you have 15 for this answer? Since these have the same log bases, 2x plus 15 is 3x. Huh? See how these have the same log bases? That means that 2x plus 15 is 3x. Back 2x, x is 15. Equal to each other. Yeah. That's all. Alright. Now the fun stuff. Words, 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 blah, blah, blah. I don't see the same log bases on both sides, do I? Since I don't have the same log bases on both sides, I have to create it. Thank you, sir. You wait till you get done. Is that all right? Now, think about the rules and properties of logarithms. We've already talked about log base b of b to the x equals x, right? That also means that b to the log base b of x equals what? Are these the same bases? Or is it equal? So what I need to do here is called exponentiating the log. What? Take a look. It's actually much easier than it sounds. What's the log base on this problem? 5. Now what I want to do here is I want to create something to make this look like this. I need to get these bases to be the same. Since this is a base 5, what I wind up doing is doing 5 to the log base 5 of 3x plus 1. Exactly, which means I have to do 5 squared over there. By doing that step, those two bases are now identical, which allows the exponent to drop. And you get a two-step equation.
Did you make it 5 squared because of the 2 there?
Because I put a 5 base over here, I put a 5 base over there. Since this was a 5 here, I put the 5 here. I have to put that there as well. If this was log base 7, this would have become 7 squared. If it was a
5, yeah.
if this could have been 9, it could have been 5 to the 9th power. It could be whatever it is. This number becomes the exponent. This number becomes the base. Okay. What I'm doing is I'm creating a problem that looked just like the first problems we did. 5 to the 3x equal 5 to the 2x plus 1. I'm creating this problem by working with the properties of logarithms. Okay. So now you wind up with x is what? 8, we agree? Okay. So try that one with this. It's the same general idea. I have log base 2 of x equals -1. So I have log base 2 of x equals -1. What's the base I have to use on both sides of the equation? 2. Very good. So when you write these problems out, one of the easy things to do on the next line is just to do this. So I know now that 2 to the log base 2 of x is x equals 2 to the -1, so x is 1. Yeah, it's to the -1. Remember, this value here becomes the exponent here. All right? This base here becomes the new base there. Okay? I don't know. People are a lot smarter than me. Are you calling me not smart?
If if I was in a position to say that, I think I'd be the one teaching this class, not you.
Are you kidding? I just thought about that too. Like, who comes up with this? Nerds.
Why do you need logarithms in the first place?
You use them a lot
For
later.
calculating?
Later, you will. There's a lot of practical stuff for logarithms. We're just learning the properties right now. We're not solving. Take a second and solve this one. See if you can figure this one out. There's multiple steps to this. Don't condense it. People try to condense this one right away. You can't. You cannot condense this. Yes, I'm condensing the cadenza. So the cadenza, right? Crescendo through the cadenza. Not an equation. Not an equation. Condensing and expanding are just with statements.
I don't know what to do at that part. Just skip it.
When the numbers place in front of the logarithm mean that number's being multiplied by the log?
Correct.
You can divide it.
Correct. Then you're doing it correctly.
I'm not doing it.
I don't know what to do at.
No, I didn't say you were doing anything incorrect. I was telling her she was doing it correctly.
No, I know, but then you
You're
want-
doing it correctly.
Well, yeah, I got this written down stuff.
Okay, what does this say? All right, what does that mean? What numbers are that?
Is it just a
Good chance. You all right? See rather. Huh? Okay, you're doing fine.
Okay.
Now use your properties. You're doing fine. You're doing just fine. You're doing just fine. I don't know.
You do it already?
What's your first step, ladies and gentlemen? I agree completely. Yeah.
Subtract 15.
Subtract 15. Do we agree by subtracting 15? Okay. Someone didn't do that first. So you want to know what 2 log base 2 of x is 16. Now, when it says 2 log base 2 of x, that doesn't mean the 2's can drop away at all. This isn't an exponent. This is just a number being multiplied. So divide. Now you have the log base 2 of x of 8. Now you do the 2. X equals 2 to the 8th power. 56. Good work. It's not that scary, is it? It's scary-ish. 2 to the 8th. Yeah. Well, you know, you also found weird things in your own. So. What'd you do? What'd you do? Yeah, no, I see what you did. No, that's fine. That's fine. It would have worked. Yeah, it's all right. I mean, just wouldn't have done it that way, but it would have worked. Yeah, try not to do any of that condensing or anything or the expanding stuff unless it tells you to, because you could wind up with some weird stuff. That's all. Okay. All right. What do you do? Very good. It's base 10. Everybody remember that? Why it's base 10? Because there's nothing. It's big. It's heavy. It's good. You can put a little 10 here if you want. So now it just becomes. What is what? Okay.
I was like, x squared or x cubed, that's 30.
Log base 3 of 2x minus 1 equals 3. You have to exponentiate both sides of the equation. Expediently. Expediently exponentiate the equation.
What?
Excitedly. Excitedly, expediently exponentiate the equation.
This is an enigma.
That's so funny.
13. It's 513. It probably is.
Oh, Bob said.
16?
I don't know why I got that. It would have been 32.
Yeah, right, there we go. Alright. Not as scary as you thought, I hope, right? Okay. I'll let you worry about extraneous solutions on your own.
Did you get 14?
Yes, I did. Now, once again, all I did here, the problems, hold on. The problems look like there's a lot because all I had to do was just cross out the ones that have natural log and e. So since we're not dealing with natural logs and e's, that way I just wrote them through. All right? So there's a boatload there. We'll go over this stuff tomorrow. You got a little bit of time. Let me just stop where this is recording.